Okay, I'll try and go through mixed practice 18, all the even questions. I'll just go through them, I think. Question 2, hopefully you've got the questions in front of you. I'm going to start with a diagram, even though there's not much to say. So we've got driving force and an acceleration, we're guessing. And we're asked to find the mass of the car. So what do we actually know? Let's go back to the question. It starts from rest and gets to a speed of 12.6 meters a second in 10 seconds, and we're asked for the mass of the car. Well, the mass of the car must come from a Newton's second law equation. Now we know a driving force. We don't need acceleration or mass, but here we can find the mass. So what I'm going to do is, from those two equations, I'm going to use V equals U plus AT, which gives us that A is V minus U over T, 12.6 over 8, 1.575 meters a second squared. Oh, almost looks magical, hasn't it? 12.6 divided by 8. Oh yeah, it was excellent. 1.575. Now we can apply Newton's second law. Say what you're doing every stage, okay? So here, quote the formula, then rearrange it. State it's Newton's second law. So we've got the resultant force is mass, which we don't know, multiplied by the acceleration. So the mass is 1360 divided by 1.575. So that's 1360 divided by the answer 863. What's that? 3 sig fig, 3 sig fig, 1 sig fig. Right, 2 sig fig must be appropriate, mustn't it? 860 kilograms. Right, that's question 2. Question 4. Van of mass 1600 kilograms, travels on a straight road, engine produces constant driving force, total resistance is, find acceleration of van. Where do we start? Where we always start. And I want you to chorus that in the background. Where do we start? Diagram. 2170, 865. Acceleration is what we're asked to find. So, Newton 2 applied horizontally, resultant force is equal to mass times acceleration. So the acceleration is going to be 2170, take 865 divided by 1600, 0.816. 3 sig fig, 3 sig fig, I'm going to leave it as 3 sig fig. Units. Part B, given it starts from rest, take time taken to travel 260 meters. The cousins of Newton 2 are the Suvat equations, aren't they? Or we might find a more complicated one, some calculus. So, starts from rest. Acceleration is 0.816. How long does it take to travel 260? And we want a time. That one is soak under tap, half a square tea bag. Don't worry, these are on the formula sheet. So look what I'm doing again. State what I'm using and sub it in. So we've got 260 is 0 plus 0.5 times 0.816 times t squared. So what's that? T is the square root, double, divide by 0.816. What's that give us? Square root of a fraction, 520 on top, y12 underneath. Oh, 25.2. 3 sig fig, 2 sig fig, 2 sig fig, I think this time. 25 seconds. So that's questions 2 and 4. Let's have a look at question 6. Question 6 says, that's 90. Question 6, a particle is in equilibrium. Equilibrium, and it's in vector notation with 3 forces, so I would always start with equilibrium. The total of the forces is 0, and I always respect the vector. So I'm simply going to write in column vector form, just to save me the i's and j's, that force added to that force, which is 2.1 there, and we're just doing it slowly so we get the signs right, plus this force adds up to give 0. We should put as a 0 there and a 0 there. What does that mean? It means the I components are 0. So that P must equal, if I put those two things on the other side, 3.7 takes 6.3. I can do that, can't I? 2.6. And Q must be both of those on the other side, minus 1.7, take 2.1, minus 3.8. Now, does the question wants the values of P and Q? Right, I've got the values of P and Q. The force F3 is now removed. Find in vector form the acceleration of the particle. Right, so A, B, acceleration of the particle, in vector form F equals ma. Right, vector, underline it. Scalar, don't underline it. Vector, underline it. So the resultant force is those two added together. 6.3 take 3.7. 1.7 and 2.1 is equal to, question 6, a mass of 2.5 kilograms. The mass, not in vector form because it's a scalar, and the acceleration. So the acceleration is going to have two components. Oh, actually, no, I'm just going to write it as A. That's as easy as it needs to, because all I need to do now is going to be this, which actually we know is going to be 2.6 and 3.8. It's calculate paper, check that again, and we're going to divide that by 2.5. I could show off and say 2.5 is 5 over 2, so I'm multiplying by 2/5, or I could just write 1 over 2.5. So it's going to be 2.6 divided by 2.5, which is 1.04, and it's going to be 3.8 divided by 2.5, which is 1.52. Find in vector form the acceleration of the particle. Just be careful here. Had they asked for the magnitude, but they didn't, we would be doing this, okay? You'd be using Pythagoras on the components. If they had asked for the magnitude, but they didn't, they asked for that. And that would be in meters per second as well. What am I doing as I go through all this? I'm stating my assumptions and I'm stating what I'm using, aren't I? Never forget to do that. Right. So, question 8 now. Question 8. A lift of mass 400 kilograms is raised vertically by a cable attached to the top of the lift. In the next chapter, we're going to do some fantastic lift questions involving the forces between people in the lift and the lift floor. This is not one of those questions. This is far simpler. So it's 400 kilograms. So the whole thing has got a weight of 400 G. And the G stands for acceleration due to gravity. There is a cable attached to the top. So there's a tension and it's accelerating. It's being raised vertically and it accelerates constantly from rest, A. Modelling the lifted particle, find the tension in terms of G. Right. The only way we're going to be able to work through this information is going to be Newton 2 vertically. So we would get T take 400 G is mass times acceleration, which is not one of the options. All right, if we find acceleration, can we find the acceleration? It accelerates from rest. Constantly, it accelerates constantly. There's a clue, but it's through that. From rest to a speed of 2 in 10 seconds. If we find acceleration, we can put it back into Newton 2. So we've got V, U, A, and T. So state the rule we're using. That gives us A is V minus U over T, which in this case is 2 take nothing over 10, 2/10, which is 1/5. Therefore, from that Newton 2 equation, T is the 400 times a fifth plus 400 G. G does not stand for grams, it stands for acceleration due to gravity. But since that appears in all the answers, I don't care that they haven't said 9.8 or 10 or 9.81. A fifth of that is 80. Hopefully this matches one of the answers. Otherwise I'll have to re-record this. Oh, that's nice. The A. Right, A. Okay. What have I done again? State what we're using, okay? Otherwise you won't get the working marks. Don't bother telling me, unless that was a multi-choice one, I'd really work for 1 mark. Then every other sort of question, state it. Question 10. Right, by now hopefully we're spotting keywords, clue words. A body rests in equilibrium. Equilibrium implies all the forces balance. On a smooth floor, no friction. 4 children pull the box. They use 3 light extensible ropes, all in the horizontal plane. The tensions in the rope are shown in the diagram. 4 children using 3 ropes. Right, there's clearly a mistake there. It's 4 children, 4 ropes, isn't it? Let's not worry about that. If we're looking, if they're all in the horizontal plane, we're looking down on the diagram. That's key, isn't it? That's key in this case. So we're looking down on. Why am I worried about that? I'm trying to work out if I need to add the weight to the diagram. But from the way it's worded, we are looking down on 4 children and 4 ropes, aren't we? So we haven't yet worked with angles yet. So the safest way of doing this is in vector form. And then we will worry about the fact that it says the magnitude of this force and the angle with the 102 Newton force. I'm going to worry about at the end. So they're in equilibrium, they add up to 0. So T plus, so we've got that one there is 86 to the right and nothing up. That one's 102 up, nothing across and 102 up. This one is nothing across and 150 down. And they all have to add up to 0. So by my reckoning, that makes T, and look again, underline the vector, show the examiner you know what you're doing. Respect the vector. Respect the vector, okay? That adds up to minus 48, so on the other side that'd be 48. Right, the tension is that. But it says it wants the magnitude of the tension. How does that change it? Right, we're mathematicians, we hate writing essays, so that's the symbol for magnitude. Square root of 86 squared and 48 squared. Remember, if we're squaring and adding, the magnitude's the size. Doesn't matter whether it's positive or negative, it's going to give the same answer. So, can't do that in our head. 86 squared plus 48 squared is 10 root 97, which is 98.5. 2 sig fig, 2 sig fig, 3 sig fig, 98.4, so that's 98 for consistency. Does it matter if you put 3 sig fig? No, 2 or 3 sig fig. Just don't put 8 sig fig, you'll lose them out there. Right, how are we going to find that angle there? At this point, I probably would draw a second diagram, but on the exam I wouldn't do it in a different colour because it's all going to be in the same colour. So we want this angle with a force which is 86 in that direction and 48 up. Okay, so your SOHCAHTOA, opposite side, adjacent side, tan theta is into the vector mode. Tan theta is opposite over adjacent. Okay, theta is tan minus 1 or arc tan. You'll see that written. Now I'll put the brackets in. Oh, fraction. Right. If you do that one in your head, I'll be impressed. 10. Oh, shall I check we're in degrees mode? Yeah, we are in degrees mode. Fraction. 86 divided by over 48. 60.8, so 61, 2 sig fig, 2 sig fig. Right. What am I doing all the way across this page? Stating assumptions, drawing diagrams, drawing a second diagram where I need it. Remembering that magnitude has a method, and so does finding a direction. If you're not sure what direction they're asking for, draw the diagram and show the direction you've worked out. And then, if it's not the one they've asked for, you've got everything but the final mark. Okay, CGI. Which brings us to questions 12 and 14. So, question 12. A car's travelling at a speed of 20 on a straight road. Driver applies the brakes and a constant braking force acts. Okay, so car, all diagrams are boxes. It's travelling in that direction at 20. Single-headed arrows velocities. Single-headed arrows from forces originating from the object. So a braking force, let's just call it F, and it's going to accelerate that way. We don't know the mass, we don't know anything else. What does the question tell us? After the car has travelled 75 metres, it's going to be a SUVAC question, isn't it? Distance. Its speed has been reduced. Its speed is now 10. All right, so, and U was 20. What are they asking for? Oh, acceleration, right. So that's not relevant yet for A part 1, is it? A part 1. So V, U, A and S, it's on the formula sheet, but at some point it'd help if you learned them. Is it crucial? V squared is U squared plus 2AS. Acceleration would imply that the acceleration is V squared take U squared over 2S, which is 10 squared, 100, take 20 squared, 400, divided by 2 lots of 75, which is 150. If anyone writes that 10 squared take 20 squared is 10 squared, you deserve shooting. Am I really going to work this out like that? Of course I know 300, right, 2, so minus 2 meters a second. That's nice, isn't it? Doesn't always work like that. 2. Time taken for car to reduce from 20 to 0. Well, twice as long. Oh, except we don't have the time already, do we? So right, let's see what we got. From 20, so not from 10 to 0, from the original 20. 20, 0. A is minus 2. Really? Time taken? Right, okay then. Happy with that. So V is U plus AT. T is V minus U over A, which is minus 20 over minus 2. Now, of course, we can do that in our head. 10 seconds. Right. Part B. The mass of the car is 1400. Given that the constant air resistance is 200, right, so we need an extra force there. Acts on the car. Find the magnitude of constant braking force with an EA. Abysmal. Right, we're going to do it properly. Right, so it turns out this is going to be our Newton 2 bit. So there is a braking force, not the way they've spelt it, unless it's so big a force it does break the car. They're different meanings, aren't they? So we don't know the braking force, which I've called F. We do know that the air resistance, which is also slowing it down, is 200. We know the acceleration that way is 2, but to the right is -2. And we know the mass of the car. So this is now Newton 2. Why am I not going to write it in vectoring form? It's all in a straight line. I can keep it in this format now, can't I? So F equals ma that way, or I could write Newton 2 that way. It's equivalent. F plus 200 is mass of car 1400 times 2, 2800, take 200, F is 2600 newtons. Right, how much space is the next one? That's a red question. Let's get a new sheet on the PowerPoint. Insert new sheet. Brilliant. Question 14, we're on a roll now. 14. 4G, mass of 4 kilograms acts under the influence of these forces, 12, 10, 18 and 13. Well, let's put those in vector form. 18, 0 minus 13. Of these three forces, no other ones, find the acceleration. Right. Newton's second law says F equals ma. Because this is in vector notation, I'm going to use vector notation. What is F? That F is the three forces beginning with R, reaction, resistance, resultant. This is the resultant, okay? I'm going to 22 minutes. Let's see if we can get this done by 25 minutes. Is resultant. So stop gassing, resultant force. So 12 plus 18 plus 0, 10 plus 0, take 13. I'm adding the three forces to get the resultant force. Is the mass 4 times A. Don't know A, so A is 30 minus 3 divided by 4, which I reckon is 7.5 minus 0.75 meters per second squared. Yeah, vector form or magnitude. No, leave it like that. If you want to work in IJ notation, absolutely fine. It's exactly the same thing. A fourth force is added so that it moves with constant velocity. All right. Constant velocity implies acceleration is 0, implies equilibrium. Therefore, the total of the forces is 0. Find the magnitude of the new force and the angle it makes to the 18 Newton force. All right, the 4 force must be the opposite of that. That was the resultant before. That implies F4 is minus 33. Excellent. Oh no, because it wants the magnitude of the force. Right, we're lazy mathematicians. Magnitude of F4 is the square root of 30 squared and 3 squared, which is the square root of 909, which can't be any different from 30, can it? Let's have a look. 909, 30.1, 2 sig fig, 2 sig fig. I'll write it as that. But 2 sig fig, that's 30. Write that answer, 2 sig fig. The angle it makes with the 18 Newton force. always a diagram, okay? Always a diagram. Let's shift that way a bit. So we've got an 18 Newton force, and I've got a force which is 30 that way. Again, on the exam, it's all in one colour. It's 30 that way and 3 that way. So the angle with the 18 Newton force is this one. But I'm going to work out this angle in the right angle triangle. So tan theta is 3 over opposite over adjacent, which is a tenth. So theta is 10 minus 1, 0.1, shift tan 0.1, 5.7. So alpha is 180. Take that. My brain really has gone to pot. 1/7, right. 2 sig fig. And right, that's 174. I know it's a bit inconsistent. Right then, that's the exam questions for that exercise. Now that's a good place to finish. Good luck with those.